Hi, welcome back to Chem with Go. This is Mr. Go, and today we're going to take a look at hydrocarbons and their formulas, and take a look also at the what I call the degree of unsaturation in their formulas, and how we can use their formulas to determine whether or not they're cyclic structures, or whether or not they have double bonds, or maybe even triple bonds. Now again, we're only going to focus on hydrocarbons, which means that these are molecules that have only carbon and hydrogen in the formulas and in their structures. So if we take a look at this first formula right here, this is a saturated molecule. This is a formula of a saturated hydrocarbon. Saturated. Now what does that mean if I have something that's saturated? What that means is all the carbons have the maximum number of hydrogens that they can hold. And all of the bonds between the carbons are single bonds. So these are more likely alkanes. For example, I can have a structure that looks like this. So this will be propane. This right here would be butane. Okay. I can also have structures like this, 2-methylpropane. I'm sorry. Or I can even have structures like this. Let me clean that up a little bit. This would be, what I'm trying to draw is 2,2-dimethylpropane, or you could even just call it dimethylpropane, since you don't really need to indicate that it's on the second carbon, because it's the only other place that you can put two methyls without it becoming a butane or something else. So these are all saturated hydrocarbons. Okay, so now let's take a look at the second set. Now you'll notice that the formula for this second set that we're going to draw right here has two less hydrogens that are present. So these right here were eliminated. And because we took out two hydrogens from the formula, what that means is increased a level of unsaturation, or a degree of unsaturation. Now, what does that mean? Well, what that means is a double bond is present somewhere in the formula. So this is now C3H6, which becomes propene. And if we go back to this original formula up here on top, though if it was saturated, then I'd have this formula, and this is propane. And the formula is C3H8. And as you can see, the difference in the formulas is two less hydrogens, because now there is a degree of unsaturation at this stage. Now, that's not the only kinds of structures that we can draw for that. A double bond, yes, is a degree of unsaturation, but if I create a cyclic structure, like for example this, which is cyclopropane, cyclopropane is also a C3H6. So these are actually structural isomers of each other. So if I create a cyclic structure, it has this formula right here. If I have a double bond somewhere in the chain, then it has this formula. And note that it can only have one double bond somewhere in the chain. All right, so let's take a look at the last one. Now you'll note that there are now 4 less hydrogens compared to the very first one right here. Okay, and the 4 less hydrogens means that there are 2 levels of unsaturation. Now what does that mean? Well, you could have a triple bond, and this is ethyne. Okay, you could have 2 double bonds somewhere in a chain, and that would be 1,3 pentadiene. You can have a cyclic structure like this with a double bond right there. That is cyclopentene. And so on. So the formulas, Okay, the 2n plus 2, the 2n, and the 2n minus 2 help determine what levels of unsaturation are present in the hydrocarbon. And hopefully I've given you enough examples, and I'll see you again soon.